Okay, so this is another register that I've got for my DIY CPU, my 8-bit TTL CPU that I'm trying to build. And this is, again, like in the previous video, this is an 8-bit register. So all it does is it's connected up to the data bus, which is just here at the top, and data, an 8-bit number, arrives on the data bus and is stored in the register. In fact, in this case, it's stored in these two chips here, 4 bits in this chip, 4 bits in that one. I think it's, yeah, least significant 4 bits in that one, most significant 4 bits in that one. And then for visual effects purposes, the data passes through to this these 8 LEDs in this array here, and then comes out the other side of there and goes into this octal buffer. So it's just a buffer, 8-way buffer, back onto the data bus and back to the back at the top to what I'm using here is my Arduino to simulate having some other interesting things on the data bus, which, because at the moment there's nothing on there. And I've done this one on stripboard. So on this left side, I've got 8 strips. That's the copper strips going up and down on these ones, not side to side. So I've got 8 strips here for my data bus. So the data comes in here, it's picked off the data bus and into the chips, and then it's put back onto the data bus and goes back up to go back to where it came from. And I think I prefer this to breadboard, because on the breadboard the wires kept popping out and I'd put it away in a cupboard, and when I got it back out it stopped working and I got all sorts of loose connections. Whereas this one, although it's a little bit of spaghetti with my wiring, it's very reliable. I can sling this in a box somewhere. When I get it back out the next day and plug it in, it works perfectly every time. So I'm pretty pleased with this one. Now, what I'm not so pleased with is that I used this IC down here, which is the octal buffer. And the reason I'm not too pleased on this one, if we look at the data sheet for it, 74HC244, the problem with it is, well, it's 2 4-way buffers with individual output enables. I'm not too worried about that, but the problem is the pin out on it, which is just crazy. There's pins coming and going everywhere. Look, the signal comes in on this side, 1A0, and goes out on this side, 1Y0, but then you've got 2A0 going out to 2Y0, so it's just crazy. I don't like that chip at all. I'm not going to use any more of those. They're too hard to wire up. Look, I had to put wires everywhere. The blue ones are going to the data bus. I'd much rather if there were 8 going to the data bus on this side, and on this side I could just use the strips on the stripboard to go up to there. But anyway, I've got better chips now because I've got the 74HC541, which does a much better job. Well, does exactly the same job, but it's got better pinouts. I soldered on the LED display on this one, and you can see there's a little single inline resistor pack just below it there. It's a 330 ohm resistor packs. There are 8 resistors and a common ground on the right hand side here. I think the LEDs are well bright enough with 330 ohm resistors on each one. Now, one interesting thing about these chips here is, if you look at the data sheet for those, the 74HC193s, which are presettable synchronous 4-bit binary up-down counters, which means they're not just capable of storing a number, but they can count that number up and down as well. And you can set a number into them, so they're actually pretty clever things. So if we look at the diagram, well, let's look at the pin out here. You've got, unfortunately it's a little bit scattered around, but you've got 4 data lines, D0, D1, D2 and D3, that's data in. You've got 4 Q lines, Q0, Q1, Q2, Q3, that's data out. But then you've got a clock pulse for up and down with a carry for down and up coming out the side. you've got a master reset which brings it back to 0, and you've got this parallel load pin here. You take that low to store a value in there. So you can put a value in this register, and then you can increase or decrease that value. So at the moment I've got my Arduino sending random 8-bit numbers into the register, storing them. So they come in, it stores them, then it reads them back again. And that is just a test that the data is going in and coming out correctly. And at the top right corner of my register, I've got 5 additional lines. So I've got about 8 data pins there, D0 to D7. Got ground and power. It's all running at 5 volts, just taken off the Arduino's 5 volt output pin. And then I've got 5 connections here. That one's reset, which I don't really know why I connected that up. I might as well have just taken that, whatever it needs to be, low, and not bothered with that, because I don't think I'd ever want to reset the value in my register. Then I've got the pin to write a value to the register, and a pin to read the value back from the register. So basically read in from the data bus and store in here, and then write the data back to the data bus on those two. And then over here I've got the count up and the count down. So let me just see if I can change my Arduino program and get it to count up. Yep, here we go. So we've got the traditional and very familiar pattern of binary counting going on there. So it should be counting up. There we go, 128. Keep going, nearly there. And when it gets to the top, it will just wrap round and go back to 0. So that's counting up is done by pulsing, by clocking this pin here. So this is the up pin, and I can change that to the down pin, so we decrease. So here we go. We should be putting the what was that? Oh, there we go. So I've programmed it now to do. So the Arduino is sending through just a series of. It's just basically clocking the countdown pin. So what you can do on this register then is store a value, and you can increase it and decrease it. And I was thinking I might use a register. I could probably do with an increase. Say this was my accumulator. I could use an increase A and a decrease A as 2 instructions for my CPU. So I could load A with 27, increase A to up to 28, and then read from A and take that value of 28 back into somewhere else inside my CPU. So it could be useful, although I'm not sure. At this stage, still thinking about it. What is quite interesting is I've written a program to test how fast this thing can run at. So it's kind of a speed test, and I wanted to do that just to check how stable this this CPU is going to be. So if I can run my speed test now, it's still counting down. There we go. So now it's putting random numbers in and reading them back, and it's doing them so fast that basically it looks completely stationary. There, it's finished now, and my speed counter, I don't know why it says starsec, but my speed counter performs 10,000 tests. Started at 0, which is reading from millis, so 0 millis. Can that possibly be true? And ended up with 3,561 millis. So it managed to do 2,808 tests per second. So let's just run it again and see if we get 2,808 again. Can't see why we shouldn't. Starting. Is it starting? No, it's finished already. 2,808 is exactly the same. Look, 2,808 tests per second. So it's capable of it's capable of storing data into the register and reading it back 2,808 times per second without a single error. Each time it writes a value, when it reads it back, it checks it's got the value back correctly. And I haven't been able to go any faster than 2,808, not because of a limit of the register, but because of a limit of my Arduino. Well, it's probably my Arduino programming skills, so that's going flat out as fast as the Arduino can go. I think I've got to do a bit of research in how I can write Arduino programs a bit faster than that. But basically what we're saying is we're clocking my register at nearly 3 kilohertz, and I'm managing to write an 8-bit number into the register from the data bus and read it back onto the data bus without losing any data at all. I tested out my other register that I did on Breadboard, and that got pretty much exactly the same number. So I've come to the conclusion that it's the Arduino that's setting the speed, not a problem with the register. There's no limitation. There's no speed limitation on the register that I can get to so far.